Hello dear students, hope you all are fine and doing study honestly. This is the next part of the series Human Eye and the Colorful World. And in this part, I will explain prism, dispersion of light and formation of rainbow. Let us see what is a prism. This is the symbol of prism and this is a schematic diagram of the prism. A prism has three rectangular surfaces. One is called base of the prism and other two surfaces are called refracting surface of the prism. It is made up of glass. A prism is a refracting object made of some transparent material having at least two flat surfaces which form an acute angle that is less than 90 degrees with each other. A prism has a triangular shape, also called triangular glass prism. It has two triangular surfaces, this and this, as you are seeing in the picture. ABC is a triangular shape face, EFD is a triangular face, and three rectangular surfaces. This is called base and these are called refracting surfaces. So base of the prism, refracting surface and angle of prism. These three parts are important for a prism. So first see base of a prism. The rectangular surface at the bottom is called base of the prism. In given figure, BCD is the base of the prism. Rectangular surface BCDF is the base of the prism. Refracting surface, the rectangular surface on which light falls and the rectangular surface through which light comes out of the prism are called refracting surface. In the given figure, ABEF and ACDE. ABEF and ACDE are the refracting surface. This is ABEF and AECD. These two surfaces are refracting surface of the prism. Angle of prism. This is very important. The acute angle made by joining of two refracting surfaces is called angle of prism. In given figure, angle A is the angle of prism. This is the angle. This is the angle of prism. When two refracting surfaces meet, an acute angle forms and this angle is called angle of prism. So this is the explanation of prism and three parts are important: base of prism, refracting surface and angle of prism. I am repeating it again. This is the base of the prism and these two surfaces where light fall and from which light comes out. These two surfaces are called refracting surface and this is the angle of prism where two refracting surfaces meet each other, forms an angle. This is the angle of prism. Now let us see what is dispersion of light. Before explanation of dispersion of light, there are some important terms related to prism. See, when an incident ray falls on the prism, this is the path followed by the incident ray, and PQR is the incident ray, RS is the refracted ray which is parallel to the base of the prism, then ETU is the emergent ray. Angle A is called angle of prism, angle D is called angle of deviation, R angle I, this is angle of incidence, R angle of refraction, and E, most important, angle of emergence. Now see what are the points. Incident ray, PQR is the incident ray, refracted ray, this RS is a refracted ray, emergent ray, STU is the emergent ray, angle of incidence, here is angle of incidence, angle of refraction, this is angle of refraction, angle of emergence, angle E is the angle of emergence, angle of prism, A is the angle of prism, angle of deviation, this is angle of deviation. How it forms? When the incident ray falls on the prism, actually this is the imaginary path of incident ray. When we produce the line when we produce it with dotted line forward and the emergent ray with dotted line backward, then there is a point where two rays meet. I repeat it again. This is the incident ray, and when we produce this incident ray forward and this emergent ray backward, there is a point where these two rays meets and forms an angle. So this is called angle of deviation. So these are the important terms related to prism, and now we will see the dispersion of light. Dispersion of light. Dispersion means splitting of. So actual meaning of dispersion is to split. Dispersion of light means when light falls on the prism, it splits up into 7 constituent colors. This phenomena is simply called dispersion of light. So it is the phenomena of splitting of white light into its component in various colors. The band of 7 colors which we obtain in the screen is called a spectrum of light. This is the prism, and a white light falls on the prism. It splits up into its 7 constituent colors, and the colors are violet, indigo, blue, green, yellow, orange, red. This is the spectrum which we obtain on the screen. That is, the band of colors which is obtained in the screen is called a spectrum, and dispersion simply means splitting of white light into 7 colors. The spectrum consists of 7 different colors of light. It is if a beam of white light incident on a refracting surface of a prism, it splits into its component colors. The colors towards the base of the prism, violet and red colors, is at the top of the spectrum. It means violet color bends the most and red color bends the least. The different color of light bends at a prism at different angle with respect to incident ray. So in this diagram we are seeing that violet color which is bending the most and red color which is bending the least, and different colors of the light bends with different angle of incidence with respect to angle of incidence. Means dispersion is what? Simply it is the splitting of white light into its constituent color, and different colors bends with a different angle of refraction. This is the phenomena of dispersion. Why light dispersed? This is the question. Before explaining why light dispersed, when it passes through the prism, we will see the wavelengths of different colors which we obtain on the spectrum of light. That is, we have obtained 7 colors, and the different colors have different wavelength in nanometer. I have prepared a table for that. Violet has the least wavelength, that is 400 to 439 nanometer. Indigo 440 to 459 nanometer. Blue 460 to 499 nanometer. Green 500 to 549 nanometer. Yellow 550 to 559 nanometer. Orange 600 to 629 nanometer, and red 630 to 700 nanometer. In this table, it is clear that violet has the least range of nanometer and red has the most maximum range of wavelength. And from the table, it is clear that different colors of light have different wavelength. And also we have studied a formula, that is a formula of velocity of wave in class 9. That is, velocity of wave equals to nu lambda, that is frequency multiplied by wavelength, and frequency do not change. Frequency of light remains same when it passes through the prism. And if the wavelength of the different colors of light is different, their velocity will be different. So when light passes through the prism, their velocity changes because it depends on the wavelength of light. And due to different velocity, due to having different velocity of different light, it bends with certain angles. It bends with different angles of refraction. So this is the reason of dispersion, because velocity changes depending on wavelength, and when the velocity changes, that will bend with different angles. This is the reason of dispersion. Now see the phenomena which natural phenomena which is based on dispersion of light, that is rainbow. Rainbow, a natural phenomena of dispersion of light. Rainbow appears in the sky in the form of concentric multicolored semicircular arc when the sun shines during or after rainfall. Rainbow is a remarkable example of dispersion of light. Rainbow always form in the direction opposite to the sun. What happens? Actually, there are number of tiny droplets which are suspended in the air after rainfall, and when light falls on that tiny droplets, the droplets acts like a prism and disperse the light which we see in the form of rainbow. So after the rainfall or during rainfall, there are so many small water droplets which are suspended in the atmosphere. These small droplets acts as a prism for the light rays. These droplets first refract and disperse the light, then reflect it internally. Internal reflection takes place, and finally refract it again when it comes out of the raindrop. Due to dispersion, internal reflection of light, different color reach to observer's eyes. See in this diagram, I have drawn a diagram. This is a water droplet. When light falls on that droplet, what happens? First it refract, then dispersed, and then total internal reflection takes place. Again it refract and reaches to observer eye. Then we get band of colors. First light ray falls on the droplet of water, it refract and dispersed. Then total internal reflection take place, and again light refract when it comes out from the water droplet as the band of colors. This is the formation of rainbow. Very simple, I am repeating it again. When light ray falls on the water droplet, first it refract and then dispersed, and then total internal reflection take place, and light ray again refract when it comes out from the water droplet as a band of light, as a band of color, and observers see the band of colors. This is the reason of the formation of rainbow. This is very clear. You see it, watch it again and again if there is any confusion. And this is the end of the video. In next part I will complete atmospheric refraction and scattering of light. So stay tuned and study honestly.